So a lot of change in the software development world in the past few years. We now have AI and agents that want to write PR and contribute code to our main branch. But you probably noticed that AI also sometimes writes bullshit code. So we have to properly verify and check the code that is going to be merged on main. So the development pipeline becomes very important. It was always important, but it's even more important than before. We have to verify that we are running tests and build and lint and different checks before we merge our code to main, that we're able to automatically detect bullshit code. So the knowledge of knowing how to create that development pipeline has become really important in today's age. So in this course, we are focused on CI and checks using GitHub Actions. So we're using GitHub Action as our CI tool, and we're writing checks to automatically detect that bullshit code. And one of the things that we're going to learn in this lesson, we're going to learn about the merge queue, which is an addition to your CI, to your development process. Before we dive into what is merge queue, let's discuss a big problem that the merge queue is trying to solve. Let's say you are writing a PR and you want to merge your code to the main branch. If you're working with a team of developers, you probably noticed that you go to your PR page and you want to merge your code, but you stumble on this message, which tells you, hey, you cannot merge your code because you have to first run the checks on the latest main. This means that when you run your checks on the PR, the checks, although they passed, but you run them on an old main. And what the error means is you have to rebase, you have to update your pull request with the latest main by clicking the update branch, hopefully choosing rebase and not merge, but that's a discussion for a different lesson. And then you rebase your branch with the latest main, and then the checks runs again on the latest main. The only problem is that when you do it, another developer might merge his code to main also, and then you have to repeat the process, update the branch again, run the checks on the latest main, and then hoping that no one pushes code to main and you don't have to babysit your PR, make sure you update your branch, and every time someone is pushing his code to main. I don't know if you noticed, but people that don't, a large team of developers that don't have merge queue, you see a lot of Slack messages, listen, I want to merge my code, it's really important, please do not push to main, or some messages like that. So the idea is not to babysit our PR and let our PR be merged automatically when the checks have passed, and to not have to update the branch every time a developer is pushing his code to main. And this is something that merge queue will help us to solve. It solves other problems as well, but this is a big problem that the merge queue helps to solve. It helps us to have a team of developers or a team of developers and AI agents working together, wanting to merge our code to main and not having to step on each other's toes and not have to babysit our PR will be merged automatically. So if I give an real-life example, I have here PR and I have the same problem. I cannot merge my branch because my branch have checks and they did not, those checks, although they passed, they did not pass on the latest main. So I can click the update branch and update with rebase, run the checks again. And then if no one pushed to main, I can then, the button to merge my code will be enabled and I will be able to merge my code. So this is a problem which you can go to the settings of the repository. You can go to the rules rule set. In the rules rule set, we can have rules protecting our special branches. In this course, we have one special branch, which is the main branch. It's our release branch and we want to protect it. So we'll create a new rule. So in the rule, one of the things that it's recommended to turn on is require status checks to pass. Obviously, we want to protect our branch with automatic checks. And if I expand this, I'll see the option require branches to be up to date before merging. This is turned on, and this is what's causing the checks to be run, to only be able to merge my code if the checks are running with my code based on the latest main. So this is what basically gave us this message, but I don't want to disable this. This is a good rule and it's recommended to turn on this rule. The reason we're turning on this rule is if my checks passed and they're not on the latest main, someone might have pushed code to main, that if we integrate it with my code, then suddenly the checks failed. So you do want to run your checks on the latest main because it adds reliability to your automatic checks. So this is something that we want to turn on, but we don't want to babysit our PR and having to update our branch every time. So what we can do is we can go to the rule set and we can turn on something, the merge queue, which we'll discuss in this lesson, require merge queue. And I will have here squash and merge. We'll discuss about those options later. I'll activate require merge queue, then save the rule set, and then hopefully this message will be gone and it's replaced by merge when ready. So now I don't have to babysit my PR. Even though it's not up to date, I still have this message. I can still automatically merge my PR, and it will merge my PR without sacrificing reliability. It will still run the checks on the latest main. So I can merge when ready, confirm merge when ready, and my branch will be entered into the merge queue, which will be discussed in this lesson. And in the merge queue, it will run my branch on the latest main. So this solved the problem of having to have this message when we want to merge our pull request and someone pushed code to main. So in this lesson, we are going to talk about what I just did. What is the merge queue? So the problem we described where multiple developers are trying to merge their code and they always need to rebase their PR with the latest main and to run the checks again, we call this problem the PR race. And the way to solve this problem while keep the checks with the latest main settings that we saw, the way to solve this problem is by integrating into your CI a tool that is called merge queue. So merge queue can be the solution to that problem. So merge queue automatically manage a queue of the PRs that we want to merge to the main branch. And it ensures that all the PRs in the queue will be merged in the order that they enter the queue. And it makes sure, since it knows the order of the PRs, that the checks of the PRs will include the latest main plus any PR that is ahead of me in the line. So it automatically merges those PR after it runs the check. It runs the check on the latest main plus any PR ahead of me, and it will automatically merge that PR to the main branch. And it helps you keep that flag, require branches to be up to date before merging, while not having to babysit your PR. So it eliminates that manual rebasing that you have to do yourself whenever another developer is pushing his code to the main branch. And it's a really essential tool if you have a team of developers that trying to merge their code to the same branch, which is often the case where many developers are working at the same code base. So it's really an essential tool. So if you're new to Academies, let me just briefly introduce you with what we're doing in Academies. So everything that we're going to talk in today's lesson about the merge queue, a step-by-step guide, is available at the Academy site. I'll place a link in the description. And if you're new to Academies, Academies is trying to take the open source concept to the world of software development education. This means like Wikipedia, only for software development courses and lectures. Everything is free. You don't need to enter your email. Just click the link in the description to see the full article of this lesson. Everything is completely free. We don't want your registration or email. We would appreciate any form of social support. So you can like this video, comment, share. You can also go to the Academy site, and since everything is open source, you can click the GitHub link. And you can also place a star if you like this project and want to contribute. So this, I think, placing a star on the repository, it's probably the most important social contribution you can do, because it's really going to help us, our popularity get up, and more people will be exposed to this open source education project and maybe contribute knowledge or code. So star us if you like this project, and everything in this lesson, as I mentioned, is available at the Academy site. Link is in the description. So before we dive in and talk about exactly how merge queue works, I want to talk about general concept regarding CI, regarding development pipeline. And specifically, I want to talk about the CI merging your code to the main branch and making sure that there is quality code that is pushed to the main branch. And I want to talk about that concept of merging your code to the main branch, because there is a procedure that needs to happen before you are allowed to merge your code to the main branch. And that procedure is checks, the different checks that are running on your code, and only if those different checks passed, you're allowed to merge your code to the main branch. So the way you merge your code to the main branch, we like to measure the quality of your automation process, the process that checks your PR, your code. We like to measure it by 4 pillars. And one of them is reliability. So I'm running a checks on a PR, and I want to make sure that the code that I'm going to approve to merge to main, it passes all the checks. And those checks ensures that the code that is entered to main is reliable, which means, for example, it is passing all the tests, it does not introduce major errors, and it's an overall improvement to the software, new features. Obviously, we have new bugs, but trying with tests to reduce the severity of those bugs and not introducing and eliminating all the previous bugs we had by writing tests. Doing checks on the code like linting and prettifying the code. So there are certain checks that run to add reliability to the code that you merge to main, where the overall objective is that the user will benefit the software update and the software will progress and the user will have a better product. So you can think of a software like a stock in the stock market. You generally want to invest in a stock that their graph is going up. The same goes with software development. You want your software to have a progress going upward. Of course, we have like small glitches, bugs that cause our software to maybe lower a bit, but the overall that you want is progress. We never have perfection in software, nor should we strive for perfection in our software. Aim for progress, not for perfection. So to make the progress, our software to go up, it is essential to run, for example, tests, to run end-to-end tests. End-to-end test opens a browser, open a mobile app, and actually run the test on an actual device that the user is going to use. And this ensures that the quality of our software is going up. So not to say that there will not be any crashes, or of course we can have 100% reliability. Okay, you'll always have bugs, you sometimes will have crashes, you sometimes will have downtime, but the overall is to reduce those and have a better software as you move along. As well as reliability is also those tests allow you to do stuff like refactoring, update packages without the fear of getting stuck in the past because you're afraid to change anything because you might break something. So it's add security also to the developers. They can develop new feature without the fear of breaking something that was written in the past. So one of the pillars is increase reliability. You have to make your CI increase the reliability of the software. This will make your total software like a stock that is going up. Your software will be overall better for your user. Another pillar for merging your code is velocity. So if I'm writing code, how quickly can I write my code and how quickly can I merge my code to main? How quickly does the CI need to run the checks? How long does it take? It's also in general the overall development experience. Can I develop quickly and merge my code quickly? How long does it take? Now notice that often velocity and reliability, and also the third pillar, which is cost, sometimes they I won't say contradict, but sometimes one is going over the other. For example, let's talk about reliability. Let's say I have a web application, so I have to increase reliability. I'm creating end-to-end tests. My browser is getting up and is testing my website. So reliability is that I'm opening a Chrome browser. If it's end-to-end test in the CI, usually it's headless Chrome browser. And that Chrome browser is running the tests. But Then I go to Google Analytics or some analytics tool, and then I see that a lot of my users are going into my site with Firefox as well. So I want to add reliability, so I will run my end-to-end test with a Chrome browser and also with Firefox browser. And then suddenly my CI takes longer, or my CI costs is going up because I have to add more compute resources to activate another browser. So sometimes you have to juggle between those pillars. Sometimes you have to sacrifice velocity to add reliability, or pay more money to add to the reliability or add to the velocity. So cost is obviously how much do I pay for the CI? And also cost and velocity also goes together, right? Sometimes if I want to speed things up in the automatic checks, I have to maybe make my compute resources that automatically checks, make them stronger, right? Stronger CI compute resources will run the end-to-end tests faster, right? So this is another pillar to check your CI. Now, cost obviously is subjective. Some companies have more money, some companies less, so they might pay more to increase velocity. Some will say, okay, I'll sacrifice velocity because I want to save a few dollars. So it doesn't mean that you need to strive for, it's always going to be the less amount of money. Sometimes you will actually want to pay more to add reliability and velocity. So it highly depends on the software, on the organization, on the amount of money that organization has, the amount of time they have. And another pillar is development experience. So development experience, if something in the CI fails, how quickly can the developer understand the end-to-end test that failed? What happened? Can he rerun it easily using his terminal, using his computer, using resources? How's the logging? How's the information is getting when his merging to code is failing? How quickly can he debug the problem? So when you create CI, you're trying to optimize those pillars, but none of them will be perfect. Reliability, you're going to have to sacrifice. Maybe you check the analytics, you see most of the users using Chrome, certain version, and you'll choose that browser and not choose multiple browser. Your velocity, maybe your developers will have to wait, get a cup of coffee while they wait for their automatic checks to pass. Cost, you might save some cost by reducing compute resources. Developer experience is not something that you have to sacrifice. It's just cost development time. So you have to add more resources so the developers can easily debug their problem. But the general idea is to try to work on those pillars to create the best experience to merging your code into main, while making sure your software progresses at a good speed and does not deteriorate, and the user gets quality software from update to update, get a better software each day. So we discussed about CI and checks and adding reliability. So let's talk about adding reliability by protecting your branches. One of the key things you need to do to increase reliability is protect your special branches. So in this course, we have one special branch, which is main. This is our release branch, but of course, every organization with its own needs, an organization might have different release branches. So in our case, we have one release branch, one special branch, which is main, which means I need to protect that branch. I need to add reliability to make the code that enters main, make the pull request that developers wants to merge to main, make automatic checks to make sure their code is reliable. So we need to protect those special branch, and we have, as we mentioned, one special branch in this course, which is main. So in GitHub, and I'm talking specifically about GitHub Merge Queue. So you have different solution to Merge Queue. We'll talk about it later, but GitHub provides a native solution for Merge Queue. So you can activate the native solution of GitHub Merge Queue, which is a simple Merge Queue. It is really easy to integrate because it's built in with GitHub Actions. So it's really easy to integrate it. And it really works well for simple use cases. Maybe you have a pretty small team and not a lot of PRs that Merge Queue needs to handle, and maybe not that much flaky tests. In that case, you can use GitHub native Merge Queue. Now, GitHub native Merge Queue, that Merge Queue is based on branch. So that Merge Queue is connected to a branch. Other solutions, they can have for a branch multiple queues. But in GitHub, each branch has, if you activate merge queue, you activate it for a branch. If you have, for example, we saw that we activate from a rule set can also apply to multiple branches. So if you create a rule set that apply to multiple branches and you activate merge queue, so basically you activate merge queue for each of those branches in your rule set. So GitHub Merge Queue is connected to a branch. And we activate the merge queue by going to the rule sets as we saw, and you need to go to the, you'll see an option there to activate the merge queue. And you, as we said, we need to add reliability to those special branches. So from the rule sets, you can add different options to increase reliability. For example, you can say that each pull request has to pass certain required checks. And from that rule set, you activate different options to protect your special branches. And we need to be familiar to certain rules in that rule set. Certain rules that it's important for us to be familiar with that increase reliability. So we need to go to the rule set. So if I go to the Academy site, the link in the description, you have here for this article, I created a repository. So if I click the repository here, you enter a repository rule set by going to the settings. Obviously, you don't have these options if you create a repository of your own or have permissions on a repository, you'll have settings for that repository. So if I go to settings, I go to the left side, I go to rules, and I go to rule sets. This is the section that we're talking. This is the section that allows you to add reliability by creating certain rules on your special branches. So in here, we already created a rule set, but you can create a new one. We already created a rule set that is called to protect the main branch. That rule set is named main. It protects only the default branch, which is the main branch, so it applies to one branch. And in here, you have different rules that helps you protect your main branch, add reliability to the code you're going to merge to the main branch. And we'll soon go over some of the settings in the rule set that you have to be familiar with. And this is, you also can protect branches with in the branches section, but do prefer to use the new rule sets. So you also have branches and you can add protection rules here, but this is the more classic, and you have add classic branch protection or add branch rule set. So if you have the option, prefer the rule set, this is a more up-to-date and better to use the rule set than the branch protection. That was what we used in the past. So what we're going to do is do a bit of coding time. We're going to go over the rule set settings. I want to go over a few of the options we have there, that you'll be familiar with some of the options that add reliability. That's important to understand to protect your special branches. So we'll go over those rule sets and what you need to be familiar and what you need to activate to add reliability and protect your special branches. So we want to protect our special branches, and to do this, we go to a repository, we go to settings, in settings we go to rules, and in rules we go to rule sets. And as we mentioned, in here we can set certain rules for certain refs. In here, let's say we will focus on, we have a special branch, in our case it's main. Already have a rule that targets main, but let's create a new rule just to go over the options you have when you're creating those rules and enforcement on those special branches. So I'm going to click the new rule set, and if you want to protect certain branches, you choose from here, new branch rule set. In here, you have a bunch of options that you can use to protect your branch, protect that automatic checks will run on developers that want to push code to your branch. You start with naming your rule, and the name can be anything that you want. It doesn't have to be the name of the branch. So let's say I'm naming it test. The second option is if you want this rule to be active, so we'll set it to be active. The third option is a bypass list, which means this rule applies to anyone except the people that are in the list, whether it's a developer or teams. gonna make sure it can help you say that certain rules apply to developers, but for example, they do not apply for admin developers. And fourth option is targeting the branches, which branch are targeted. And it doesn't have to be a single branch, it can be multiple branches. It can be a regular expression that targets multiple branches. So in here you say those rules apply to those branches that are in here. The three, restrict creation, restrict update, restrict deletions. Those are options that basically who can create those kind of branches, who can update those kind of branches, and who can delete. So basically no one can, if I'm restricting this, no one can create, update, or delete those branches except the people that are included in the bypass list. This, for example, I can say restrict deletion for the main branch to prevent any developer to delete the main branch, which is a good option to turn on, except the bypass list. Require linear history, I would turn this on as well. This prevents merge commits on those branches that we're talking about. So I would turn this on as well to avoid merge commits and have more linear history. Require merge queue, we're going to talk later in this lesson more thoroughly about this option, but basically this is what enables the merge queue. Now remember, we didn't yet talk about the merge queue, but remember that GitHub Merge Queue is connected to a branch, which means that if you turn this on, it doesn't mean that you activate one merge queue, it can mean that you activate multiple merge queue depending on the amount of branches that you target here. Require deployments to succeed. So a deployment is basically marking a commit that belongs to a certain deployment, meaning certain release, whether it's the staging, dev, production. You mark a certain commit as being connected to a certain release. And those are, you can do it from GitHub Actions. You set an environment in a job, and this means that that job needs to pass in order for your pull request to be allowed to merge. So this is depends if, for example, you are having a deployment to a certain environment, you might want to turn this on. Require signed commits is a security, it's a security feature. I would say turn this on as well. So this makes sure that the person that is pushing his commit, it has a key to encrypt that commit, and that can only be opened if you upload that key to GitHub, and then it can open. So it basically verifies that only a person with a certain private key that is connected to a public key can push a commit. So basically it means that if an outside developer is trying to push commit somehow, it's a security, another extra security feature that enforces that developer to have certain private key that match certain public key. Sometimes you use the same key that you use for SSH to encrypt. We'll have a lesson about side commit in the future. Require pull request before merging. I would turn this on as well. So basically this means I would turn this on at least for the release branch, for our main branch. So basically it means that if a developer wants to merge his code to the main branch, to the branch of this rule set. In this example, we're talking about the main branch. He requires to do a pull request before he can merge his code. So, and required approval, I would set this at least to 1, that someone has to review his code from the pull request before he can merge it. Dismiss stale pull request approvals when new commits are pushed. So, so this means that new commits are pushed to the main branch. So this means that the reviewer needs to go over this again. So it doesn't have to be turned on. So if your pull request, because usually I would turn the require status check to pass, require branch to be up to date before merging, and we turn this on. So this means that you dismiss the review if the pull request approved when the new commits are pushed. When someone pushed a new commit to main, your review, it becomes stale. You can turn this on or off depending on your use case. Require a review from a specific team. So again, depends on your use case. You might have different teams like DevOps, like admin, and you might want to say that all the pull requests have to be approved by admin. That's highly restrictive and put a lot of burden on certain developers. Mostly I don't turn this on, but I do turn the require review from code owners. So code owners allow you to say that part of your code you want to be approved by certain teams, or that you specify in a code owner's file. So I would not say all the PR needs to be approved by a certain person because he would spend a lot of his time checking PRs, but I would say important parts that only he is familiar with might be best to be approved by the code owner. So I would turn this on as well. Require approval of the most recent reviewable push. That means that if you approved something, but someone pushed to the PR a new commit or changed the commit, your review becomes stale and you need to approve it again. Require conversation resolution before merging. I would turn this on as well. If someone is reviewing your pull request and is writing comments, you have to resolve those comments, meaning you have to solve what the other developer that checked your code wrote on your code. You have to solve this. Allowed merge method, how the pull request will be merged into, in our example, into the main branch. I like to set it only on squash, so I'm removing merge and rebase. And I like that all developers merge their code the same way, which basically means squash. I'm squashing their commits to one and then placing it on top of main. I would definitely require status checks to pass. Some checks you set as required and some are not required. And this means that the checks that you place here, that you write here as required checks, those checks have to pass before the developer can merge his code. I would definitely turn this on. I would definitely turn required branches to be up to date before merging, which basically means that if the developer is doing a pull request to main, his checks is passed, but someone pushed a new commit to main, their checks are now irrelevant. He has to rebase his branch with the latest main and run the checks again. This ensures reliability, that your checks passed against the latest code, because someone might push the new code that's when combined with your code is causing the checks to fail. So this adds extra reliability. I would definitely turn this on. Do not require status checks on creation. Some checks starts later on, not immediately. For example, you might want to run the end-to-end test after the build is finished. So if that's the case and some required check starts later programmatically, it means that the creation will be rejected. So you turn this on if you have a use case where missing checks, you still want creation on those missing checks that will be added in the future. So this is highly depends on your use case, but if you're trying to push to create those branches and you get a fail because you're missing checks, you might want to turn this on as well. Block force push, definitely I would turn on for my release branches. For the main branch, I don't want anyone to git push -F to my main branch. It will distort the entire history. It also doesn't pass checks, creates a whole lot of mess. Block force push, I would turn this on every time on my release branches, on my main branch. Require code scanning results. You have certain code scanning for security, for example, code QL, and you might require them to scan your code for security vulnerabilities, and you might restrict the developers from merging their code if they're not passing this scan. So depending on your use case, but mostly I would turn this on as well. Require code quality results, again, for tools that checks the code quality analysis, and they require those tools to pass, and only if they pass, it enables you to merge your code. Automatically request Copilot code review. When a pull request starts, automatically Copilot is added as a reviewer and writes comments. That depends on your use case. Restrict commit metadata. Commit metadata, you can add to your commit the author, the email, and you can pretty much set them to whatever you want. So this is a restriction that you don't write in the commit that the email of the developer that wrote it doesn't match the actual email of the user that wrote the commit. So I would turn this on, security feature, which is good to have. Restrict branch names, that to prevent certain branch naming. If you want to restrict say every branch that starts with release is a release branch and you want to restrict those kind of branch names, so you can do this as well. So just to summarize, really important things that I want to go over, some of the rules that we set, important things that we need to remember. The merge queue, require merge queue, we will go over it in this lesson. It's an important feature to understand if you have multiple developers trying to merge their code to the same branch, they stumble on each other and they have a PR race kind of thing going on, you definitely want to be familiar with the merge queue, not necessarily activating the GitHub Merge Queue. There's a solution out there, but you have to understand what is a merge queue and maybe integrate it in your CI process. I would definitely turn on require pull request. I would definitely turn on the approval. I would make sure the approval, I would turn on code owners. We'll have a lesson about code owners in the future. I would turn on the approval of the most recent push, turn on require resolution. I would definitely understand that I want all the developers to have a certain merge method, and I usually set it to squash. Status checks, this is a key element of enforcement here. So you want the CI to run checks. You want certain checks the required checks to pass before a developer can merge his code. This is super important. Require branches to be up to date. Make sure the checks are run on the latest, on the pull request that's rebased on the latest main to make sure those checks are reliable. So those are important features that help us protect our main branch or protect our special branches. So I'm enforcing those rules on pull requests that want to merge on our main branch, and then I'm making sure that the code that is merged on the main is reliable and all the checks and rules are passing to that code, and then I feel much safer about developers merging their code into my main branch. Before we start explaining what is a merge queue, let's discuss further about I think one of the major problems that merge queue solves. So we did go to the rule set and we talked about a rule set that we require status checks to pass when we create rule set on our main branch, run release branch. We want to make sure that the release branch gets reliable code. And one of the things that we want to make sure that automatic checks are passing on all the pull requests that want to merge code to our main branch. So we ticked the require status checks to pass. We enabled that to make sure that pull requests have to pass those required checks before it can merge. But we also enabled another option, which is required branches to be up to date before merging. And we enabled this to increase reliability, which means it's not only needed that the checks pass, they also need to check to pass when your pull request is in sync with the latest main. So this does increase reliability, and this is something that we want to enable. And I would say I enabled this option in all my projects. So when we enforce require branches to be up to date before merging, it ensures checks run on the latest main. But if you have more than one developer, if you have a busy repository, this can create a race condition where each developer is trying to merge their code. And when they do merge their code, they turn a lot of checks on other PRs becomes irrelevant. And other developers needs to rebase their branch and run the checks again. So as we mentioned, this option does increase reliability, and we do recommend turning this option on, but with setting turned on, it can cause a problem of developers racing against each other to merge their code to main, and other developers needs to always rebase and rerun the checks. So always you want to rebase and rerun the checks, and this becomes a problem. You have PRs that are becoming stale and hard to merge, and developers waste a lot of time and a lot of resources because they run checks, which becomes irrelevant. So, and they always need to babysit their PR. They always need to rebase, rerun the checks, rebase, rerun the checks. So it's kind of like babysitting your PR until you merge it. And some PRs, as we mentioned, get starved. It's really hard to merge them. And you start hearing messages in Slack that mentioning that hold your merges because I have an important merge that I want to push, stuff like that. So if I try to demonstrate this with a diagram, it looks something like this. If you have a main branch and you have PR, let's call it PR1, and PR1 is doing several commits, and you have also PR2. Now PR1 is finished and is running checks. So it's running the build check and is running the test check, and they all pass. So PR1 is good to merge. And PR2, which started a bit later, is also past the build and test, but PR2 is merging before PR1, which means all the checks that PR1 made are becoming irrelevant. PR1 needs to rebase his main with the branch and then pass the checks again before he can merge his code. So we call that the PR race condition problem. And this is one of the biggest problems that merge queue helps solve. So other than the PR race that we just saw that merge queue helps to solve when you have many developers trying to merge their pull request into your main branch, there are other problems that merge queue help you to solve. And I'm just talking broadly about merge queue, not necessarily GitHub, because you have other solutions for merge queue like Trunk, like Mergeify, which we'll talk later on. So I'm talking in general, taking into consideration those other solutions, what other problems they might save you. So One problem that the merge queue helps you solve is a protection against flaky test, where a flaky test is a test that can fail or success without changing the code. It's usually some kind of race. Maybe you're waiting for a query from the server and then checking something in your end-to-end test before the query came back, or some kind of race like that can cause you a flaky test. So a merge queue does give you somewhat protection against flaky tests. Now, flaky test is a problem that usually happens a lot in every repository that you have a lot of tests, a lot of end-to-end tests. You usually have some percentage of flaky tests. This is something that happens a lot. And if you understand the importance of testing and running those tests with the CI automatically, you'll probably create more and more tests. So the amount of tests can reach a lot of tests. So even if 1% of the tests are flaky, it does mean that if you have a lot of tests, they might fail a lot of runs. So having such a protection against flaky tests is actually quite important, and it does increase the velocity in which the developers can merge their code to the main branch, because if the checks fail due to flaky tests, they need to run the checks again. So it becomes kind of a holdback for developers to merge their code, kind of decrease the velocity. And since it happens almost in all code base that has a lot of tests, having tools to protect against those flaky tests will increase velocity. Now, GitHub the GitHub Merge Queue doesn't have a lot of those protection against flaky tests. We're going to talk about group, which helps a bit. But for flaky tests, if you have a lot of flaky tests, trunk probably be you should probably examine trunk as a solution, which have more tools against those flaky tests. Reduce CI cost. We talked about the PR race problem, and we saw that if you want to run a pull request and your checks and someone pushed to main, your checks are irrelevant. So you pretty much the CI that ran those checks is kind of wasted. You have wasted money on that CI that ran the checks, which now became irrelevant. In addition, different merge queue solution might offer additional feature to save CI cost. For example, if the merge queue, if you have one PR, it might not run the checks again, or it might batch few PRs together. So we'll talk about those different options that you have in other solution that helps you reduce CI costs. Now, I would say this, it seems like GitHub, I don't know if they have such a strong incentive to reduce CI cost in their merge queue solution, since they earn money from those CI costs. So they don't have a lot of features, and they don't really publish a roadmap. So it's hard to say if they're even working on implementing those features in the future. So I would say that other solutions like Mergify or Trunk do have a strong incentive to reduce CI costs. In fact, some of those features which they have might help you reduce CI costs to the extent that it covers the amount you save even more money by implementing those features on your code base. You save money by CI than the actual money you pay for that external solution like Trunk or Mergify. So in certain cases, embedding such external solutions with a lot of features that saves CI costs might even save you money. So increase throughput. So a lot when you running merge queue, we're going to talk about merge queue implementation. It runs a lot of checks in parallel, so it helps. The throughput means that it increased velocity. So a lot of developers can merge their pull requests quicker, and because it runs in parallel, then it's increased the throughput and velocity of developers merging their pull request. Reduce PR babysitting. We talked about the PR problem that you have to babysit your PR, always rebase and run checks again. So it helps you solve this. It also detects conflicts faster because you're in a queue. You can understand quicker if you're going to have conflicts either with the main or other PRs that are going to be pushed ahead of you. So those are other problems that Merge Queue helps to solve. I will say this: if you have I would say even like a team of developers that merging their code to the main branch, for example, you probably have to integrate some sort of a merge queue. Rather, it's a simple go to GitHub native kind of merge queue or go to something more sophisticated. But if you have a team of developers merging their code to the same branch, I would say this is a must in every CI in such a scenario. So what we're going to do now is we're going to enable the merge queue. And yes, I know we haven't even talked yet what a merge queue is. Rather, more we focused on incentive, but now we're going to enable merge queue, and we're going to focus on what exactly does a merge queue does and how it solves all the problems that we presented. So we're going to enable merge queue. I would say this: when we enable merge queue in GitHub, specifically we're focusing this lesson on the GitHub Merge Queue because it's the simplest to integrate in our code base, especially if you're running GitHub Actions. So the GitHub Merge Queue is only available in any public repository owned by an organization. So notice the organization here. So if you have a public and an organization, it will be available, or in private repository owned by an organization. So if you're a private user, you might not see the options that we show now to enable the merge queue. Okay, so let's enable the merge queue. So for this lesson, I created a demo repository, and I'll place the link to this repository in the video description. You also have this link available in a step-by-step guide in the Academy site. So link to the repository is on the bottom right. So in a repository, as we mentioned, you enable the merge queue from the rule set. So I go to the repository settings, and in the settings, I go to rule sets, and I already have a rule set for my main branch that I want to protect. So I'm just going to click this rule set, and I'm just going to edit this, and I'm going to look at the option of require merge queue right here, and I'm going to enable this. Now we have to remember that the merge queue is enabled. GitHub merge queue is connected for a branch. So depending on which branches you target in this rule we only target the main branch. So we're only activating the merge queue for that main branch. So I'm going to activate the require merge queue, and there is a few settings that are opening up. We're going to go over those settings later on in this lesson, but one of the settings I do want to change, and this is the merge method. I'll explain more about this merge method later on, but what we recommend to choose in the merge method is the same merge method that you choose for your pull request. So require pull request before merging. It has allowed merge method, and usually I like to keep the merge method to be identical to all developers. Just reduce the options and leave it with one option, and I recommend using squash. So just squash the PR to a single commit and then merge that commit to our main branch. So if you're using squash, you should use the same thing for your merge queue, squash and merge. So choose the merge method according to the pull request. We will also notice something else here. Require status checks to pass. We enable it to protect our main branch. If I open the additional option, I see that currently we have one required check, which is the build. So this required check is important to note because this required check is also going to be required for the merge queue. So we're going to talk about those because I see a lot of complaints of people that activate the merge queue, and that merge queue kind of hangs without doing anything. It's usually because their required checks are not running in the merge queue. So I'm going to save my changes. Now I'm going back to the code of this repository. We have a required check, which is the build, which we have a workflow for the build. So this is our workflow. So this is GitHub Actions workflow, and a workflow is a container for jobs. Each job has a compute that runs that job. It can be self-hosted, or it can be one of GitHub Actions options, some kind of computer that runs those steps. So workflow container is a container for job, and also it has a trigger. Workflow has a trigger, and the trigger is this, what you write after the on. So one of the good things about GitHub Action, it has a lot of triggers that connects to different events that correspond with your repository, like pull request, like comment, like cron job. So a lot of different events that happen on your repository. So by the way, the lecture notes that I'm putting is using an extension that we created in Academies. So an extension to help with lectures, and all those lecture notes can be later at reviews as a summary slide. So it's good for lecturers that want to create notes for their lectures, or also document your repository. So we have a link. Also, this project is also open source. We have a link for it in the Academy site. So if you like to document repository or past lectures, it's a good tool to write lecture notes. So going back to our code, so this is our workflow, our build workflow. Now, when you have a trigger, which is pull request, so the pull request trigger is also creating a check. So a check in GitHub Action can be run by either creating a workflow that runs on trigger pull request, or it can also be triggered programmatically. So the check that is created from this pull request, this is a required check. Now, in order for this to run also in the merge queue, we have to add another trigger, which is the merge group. Okay, the merge group, this trigger means, I'll delete this. So this trigger means run this workflow also in the merge queue. Okay, so this enabled the merge queue and also set a build. We set the build as a required check, and also we made sure that this required workflow, required check, is also going to be run in the merge queue. Now, this part is really important because I saw a lot of comments and discussion, developers not understanding why their merge queue is stuck. If you don't add this, your merge queue is going to be stuck because it's looking for a required check, the build, and it's not running it. So it's going to get stuck and then timeout after what you set in the settings for timeout. So this enabled the build. Now, let's try to run our code. So I'm going to add commit, create a pull request. So let's do git checkout -b each enable merge queue. And I'm going to add commit testing the merge queue. And I'm going to push my branch. And then I'm going back to the browser and I am going to create a pull request. So I'm going to the repository. I'm going to create a pull request. Now, what basically our build is doing, so let's go over the build, basically sleeps for 3 minutes. So we're going to wait 3 minutes for the build to pass. And what I'm going to do, and I'm going to click the merge when ready on my PR. This means that I don't have to babysit my PR. It's simply going to automatically move that PR to the merge queue, and then it will run the build in the merge queue, and then it will automatically merge my PR without me needing to do anything in the PR, like click to merge my code. So we'll wait 3 minutes and we'll see the result after the wait time. So after 3 minutes that we waited for the build to complete, and this is why I placed the timer, it wrote me this message in the PR. Queue to merge. This pull request is next up in the merge queue. So I can click the merge queue, and now I have the list of all the pull requests that are now placed in the merge queue. And what it does, it actually runs the build again in the merge queue. So if I go to actions, I see that my build run twice. Once in the merge group checks requested, and once in my pull request. And after the build is finished here, it will automatically merge my pull request without me needing to do anything. So what we're going to do, we're going to wait again 3 minutes for the build to complete in the merge queue, and then our PR will be automatically merged. So we'll wait for this to finish. So our merge queue is now finished. Everything to run the build again in the merge queue. Remember that we placed the trigger merge group, which means it will run the build again, not only in the pull request trigger, but also when the pull request is entering the merge queue, it will run this workflow again. So now the merge queue finished running the build again, and you already noticed that there is it runs the checks again. So even though it ran the build and the code did not change, it still ran it again on the main, which is a disadvantage in the GitHub native merge queue. If you want it to not run the build if it's on the latest, you have to create that logic yourself. There's a feature request for this. Many developers asked it like about 3 years ago, and it doesn't seem like GitHub is going to implement it. Again, it's getting them more CI runs, more CI, it costs us more money, so it's something that you have to implement. For example, Trunk have a feature that if your checks ran and nothing has changed, then it won't run them again. If we go to the pull request page, and we'll see that our pull request is now closed and merged. So we didn't have to click the merge or do anything. Our pull request is automatically merged. So we managed to enable the merge queue. We saw that the merge queue is working on our pull request. We saw that we have a required check. We set a required check for build, and we enabled to run the build in the merge queue by adding an additional trigger that is called merge group. So this is our first run, our first trial run with activating the merge queue and running a workflow and a check inside our merge queue. So we saw from the demo that we now have a new development workflow regarding how we merge our pull request. So we saw that if we go to our pull request, we don't have to wait for the checks to finish. Right now I have checks that are running. You also don't have to make sure that your pull request is up to date with the latest main. You still, without those things, can click the merge when ready and confirm merge when ready. And this will allow when the checks, the required checks are passing, in our case build is the required checks, it will automatically be transferred to the merge, to our merge queue. And in the merge queue, it will run the required checks again. And if they will pass, they will automatically, your PR will be merged to main. Now, when it will transfer my pull request to the merge queue, it will make sure that my pull request is up to date with the latest main. If there are pull requests ahead of me, it will make sure to also place them ahead of me. So it will really make sure that your code runs on the latest version before it runs the test in the checks in the merge queue. So the development flow is a bit different now. You go to the pull request, you don't have to babysit your PR. You can click the merge when ready and confirm it, and then your pull request, if everything goes according to plan, will eventually be merged to the main branch. So the development flow with merge queue is now a bit different. We have a different button to merge our pull request, a green button that says merge when ready. You don't have to wait for the checks. The checks still need to pass, right? So you don't have to wait for the checks and babysit them, but the checks still need to pass in order to transfer to the merge queue, and the checks need to also pass in the merge queue. We'll talk about different exceptions to that rule. There are certain cases where your PR is part of a group and then it doesn't have to pass all the checks if the latest PR in the group passed the checks. But we'll discuss about those extreme cases later on in this lesson. So the checks themselves still needs to pass, whether it's on your pull request page, on your PR, or in the merge queue as well. Once checks pass in the pull request, your pull request will be transferred to the merge queue. The PRs need to pass the checks in the merge queue again, but this time they might be a bit different because they might be rebased with the latest main, or they might be placed rebased with the latest main, plus another PRs will be added ahead of them. So the fact that it passes in your pull request, the checks pass in your pull request, does not mean necessarily that the checks will pass in the merge queue. They need to pass again, and your pull request might be a bit different because it might be rebased with different PRs and latest main. And if the checks pass on the merge queue, the PR is going to be merged to the main branch and they maintain the same order. So a PR enters the merge queue and the merge queue is arranging certain order of PRs. And according to that order, those PRs will be merged to the main branch. So we understand how to activate the merge queue and how the development flow works, and we did a little bit of demo of using merge queue and how it works. But let's dig a bit deeper how merge queue actually works. So when your pull request is passing the checks in the pull request, and then your pull request is transferred to the merge queue, they might be other PRs in that merge queue. So consider the merge queue as a queue of PRs. So the merge queue decides the order of the pull requests. So if you enter the merge queue, it doesn't mean that your pull request is going to be merged first. It might be merged after 5 other PRs that are currently in the queue. So the merge queue decides the order of merge, the order of pull request to merge. So a PR is merged based on its position in the queue. The position in the queue is decided by the time that the pull request entered the queue. So for example, if you click merge when ready, and the pull request is passing the checks in the pull request page, after the checks have passed in the pull request page, checks and for example, review, if you required a review for pull request. So after all the necessary things for your pull request passed, your pull request will automatically, if you click merge when ready, will automatically transfer to the merge queue. Now the merge queue decides where it's going to be placed in the queue based on the time that it arrived to the queue. So maybe other PRs arrived before it in the queue, so it's not going to be first. But also PRs might be kicked out of the queue. So the merge queue can also decide that certain PR will be removed from queue. Then your PR might be bumped in line to a more advanced place in line. So the merge queue decides the order, the PRs in the merge queue, the order of merge based on the entrance of PRs to the merge queue, as well as how do they pass the checks or not, or if they should remove it or not. So merge order is determined by each PR's position in the queue. Based on the position of the pull request in the queue, this is how the merge queue will decide to merge your PR. So if your PR is 5th in the queue, it will be it's first going to merge the other 4 PRs before it's going to merge your PR. And PR, it maintains the order. The first PR that enters the queue, and then it maintains order based on the time the PR entered the queue. If PR fails the checks, it might be removed from the queue. So as we mentioned, when a pull request is entering the merge queue, all those workflows that we saw that have the trigger merge group will be triggered and will start work. So it will run the checks that they control, maybe other programmatic checks that you have during those workflow runs. So if those checks fail on the merge queue might decide to remove that PR from the queue. And notice that I'm saying might because there are certain cases where your pull request is in the merge queue, it fails the checks, but the merge queue decides not to remove it from the queue and actually merges your pull request even though you failed the test in the merge queue. There are certain cases of that. We'll see an example later in this lesson. So if a PR fails checks, it might be removed depending on the decision of the merge queue. And if the merge queue decided that the PR is removed from the queue, it needs to arrange the pull request in a different order because it removed that pull request, and then the pull request after that one will be bumped one place forward, and it will have to, if it decides to remove that pull request from the queue, it will have to recreate something called merge group for each pull request, and it might decide to rerun the checks again for the PRs ahead of the PRs that it moved in the line. It will have to rerun those checks again. So let's see an example with a diagram of what we mean by order of merge. So you have the merge queue, which arranges a queue of PRs that pass the checks and review in their PR page and were moved to the queue. And based on their entrance, for example, our first PR with ID 123 entered our merge queue, and it starts running the checks in the merge queue. Based on the workflow that have the trigger merge group, it's going to run those workflow and it's going to run those checks, and hopefully all the required checks from those workflow runs will pass. So PR 123 is entering the merge queue, and right away it's starting to run all the workflows with the merge group trigger and running the checks. Right after it, PR with ID 91 is entered the queue as well. Notice that while PR 91 entered the queue, PR before it, 123, still running the checks. It's still running the checks. It didn't finish to run the checks, but it doesn't hold PR 91 back, and PR91 is also running the checks, they can run the checks in parallel. So 91 does not have to wait for 123. They can run the checks in parallel. So a third PR enters the queue while the other PRs are still running their checks. And again, the third PR is running the checks in parallel with the other PRs. Now, if they run in parallel or not depends on the settings that we'll go over, the concurrency settings. But let's say we have more than 3, so they can run in parallel. Notice that 91 passed their checks. So 91 is ready to be merged, but it's not merged yet because the order of the merge is based on the order that the PRs has entered the queue. So it needs to hold 91 and wait for PR 123 to pass because the order of merge is maintained by the order of entrance to the queue. Now PR 123 passed, and now they can be merged. First, PR 123 is merged. This is the order that maintained. He's the first one in queue, so he should be the first one that is being merged. Then PR 91 is merged. Notice that PR 150 is still running the checks. Their checks passed, and now PR 150 is merged as well to the main branch. Let's see another example of order of merge when one of the PR in the order is failing. So in this case, we have again the merge queue. 123 enters the merge queue first, starts running the checks right away. 91 enters the merge queue. We have concurrency, so it can run the checks in parallel. 150 is enter the queue, running the checks again. Notice that 91 checks have failed. Now, if the checks failed, in this example, 91 will be removed, but it's not necessarily. If you turn on the option to group, then the merge queue might keep it in the queue. Look at the result of 150, since 150 contains also PR91, and if that passed, might decide to also merge 91. We'll give an example of that later. But in this example, we don't have group activated, so 91 checks failed, it should be kicked out of the queue. So it's not necessarily that it's kicked when the checks failed. We'll see an example, a more complicated example of 91 fails and still being able to be merged to main. But in this example, failed the checks, meaning you're being thrown out of the merge queue. So 91 checks failed. When 91 checks failed, the merge queue decided to kick 91 out of the merge queue. Now the order is a bit different because 150 is now second in line. So he jumped one place ahead. Now the 150, because the order, the merge group needs to be recreated, it's need to restart the checks. So this means all the checks that is being run are being invalid once a PR is kicked, and they need to restart. We'll explain why that is later when we talk about merge group. So it has to restart the checks. 123 passed, it is merged. 150 is passed, and then it merged again. So those examples show you that the merge queue decides the order of the PRs that are going to be merged, the order of merge to the main branch based on the entrance to the queue and based on the decision of the checks. If the checks failed and we decide to kick it out of the queue, then it decides based on those characteristics the order of the merging of pull request to our main branch based on the entrance and if it's kicked or not. So the order of merge is decided by the merge queue. So we mentioned that our merge queue decides the order of the PR to merge. I will first merge this PR and then that PR. And it decides the order of merge based on the time of entrance of the PR to the merge queue. A PR is entering the merge queue when two things happen. When the developer clicks the merge when ready button and confirms it, and when the pull request pass all the checks and requirements. For example, certain checks are required. Maybe it requires also a review, approval from other developer. So when the pull request pass all the requirements plus the developer clicks merge when ready, then the pull request automatically enters the queue. Now, other PRs might have entered before it, other PRs might enter after it. So the merge queue is arranging a queue based on the entrance to the merge queue. So it arranges the PR based on the order that they entered the queue. Now, the merge queue might decide to kick a pull request out of the queue, and then the order might change. So the order is not carved in stone, it can still change. But since the merge queue knows the order of the PR in the queue, it knows the order of merge that is going to happen. Of course, it might kick someone out, but if everything goes correctly and according to plan, the merge queue knows what is the order that the PRs are going to be merged to main. And even if the order is changing, then the merge queue is getting synchronized again, and then after the change, the merge queue kicks some PR out, and then after the change in the synchronization, the merge queue knows again what is the order, what is the new order of the merge of the pull requests that are going to be merged to main. So the merge queue knows the future state. So it doesn't not just necessarily know what the main is now, it also knows what the main is going to be. So the merge queue will know the future state. So if the merge queue knows the order of merge of the PR, then it knows the future state of the main branch. For example, if PR with ID 120 enters the queue first, and right after that, PR with ID 123 enters the queue, the merge queue knows the order. First, I'm going to merge PR with ID 120 and then 123. I know the order, I know the future state. And I know the future state means that when I'm running checks, we said that when a PR is entering the merge queue is going to run checks again on the PR. So this means the second PR with ID 123, the merge queue knows that when it's going to have to merge PR 123, PR 120 is going to be already merged. Of course, given that it's not kicked out, PR 120 is ahead of me, so it's going to be merged before 123. This means that in order to run the tests, the checks that runs on 123 in the merge queue, we can set main plus PR 120 and then PR 123, and on that branch run the checks. This way I keep the required branches to be up to date before merging, even though PR 123 is not yet merged. Okay, so it means I can run the checks in parallel. I can run checks for 120 and I can run checks for 123, and I can run them in parallel. The way I arrange it, I arrange 120 with the latest main and 123 with the latest main plus PR 120, then PR 123, and then run the checks on that branch. Given I know the future state, I can arrange a branch that will reflect the required branches to be up to date before merging, even for PRs that are not yet merged. So I can set a branch that is with the latest main and every PR ahead of me to simulate how the main branch is going to be, so I can run the checks in something that withhold the standard of required branches to be up to date before merging. So checks for PR 123 must run on that predicted state, with PR 120 included, not on the current main. That means 123 will not run on the latest main when it enters the merge queue. It will run on the latest main plus PR 120 plus PR 123, and on that branch they're going to run with the latest main and all PRs ahead of me. So I know the future state, I can run checks in parallel while upholding the flag required branches to be up to date before merging. So if the merge queue knows the future state, it can construct special branches that we call merge group. So a merge group is a read-only branch that GitHub creates for each PR that is entering the merge queue. So the branch that it will create, it is based on the future state. So it will contain the latest main, and every PR that is placed in the queue before you is going to be placed in that branch. How those different PRs are going to be placed in the branch, that's depend on the settings that we have in the section of the merge group. So if I go to the rule set main, you'll remember that we add require merge queue settings, and in here we have the merge method. Now the PR are going to be placed before you in the merge group based on this setting. So each PR, in our example, we chose squash and merge, is going to be, we'll see it as a single commit, because their commits are going to be squashed to a single one, and we're going to see that PR in the merge group branch. So the merge group that is created for me contains the latest main. If I have a PR and that PR enters the merge queue, the merge group branch that is going to be created for me will contain the latest main and every PR ahead of me. And according to our settings, every PR ahead of me is going to appear in the merge group branch as a single squashed commit of that PR. So basically that merge group branch reflects the future state. So it reflects the latest main, every PR ahead of me, and I can run checks on that special branch that actually reflects everything ahead of me, including the latest main. So it allows me to keep the required branches to be updated before merge, right? So we had this settings that require status check to pass, require branches to be up to date before merging. So we enabled this. So since we know the future state, it allows me to construct a special branch that is with the latest main and every PR ahead of me that keeps up with this demand to require branches to be up to date before merging. So, and also the beautiful thing about it is that I don't have to wait. I don't have to wait for the PRs ahead of me to be merged to main, right? Because this branch is constructed not necessarily before all those PR are merged to main. So this special branch is constructed while the other PRs are also running their checks. So in the same rule set for the merge queue, we set build concurrency. So build concurrency is currently set to 5. So this means that we can construct 5 of those special merge group to run checks in parallel without worrying about if a PR is merged or not. It's going to construct this merge group and then run the checks in parallel. So this really speeds up the process of merging the PR, since we don't have to wait for the certain PR to finish, rebase our work, merge, run the checks again. So it's also increased velocity of the PRs that is going to be merged to the main branch. So multiple merge groups can run checks in parallel, which is the build concurrency setting. Notice that the branch that is created is a read-only branch, so you cannot push changes to that special merge group branch that is created, but you cannot push changes to your pull request. If your pull request has entered the merge queue, you cannot push changes to that pull request. You have to first take it out of the merge queue. You can do it by going, there is a URL for the merge queue. You can go and you can throw a PR that is in the merge queue, you can throw it out. If you don't do that and your PR is in the merge queue, GitHub will not allow you to push changes to your pull request. And that actually makes sense because there's a lot of other PRs ahead of you in the merge queue that created the merge group with your PR, and they're kind of basing their checks on the fact that your PR looks a certain way, right? So the merge group branch is read-only, and also your pull request is blocked for changes. The branch name that is going to be created, the merge group branch, is going to be created as, we'll see an example after this slide. It's going to name GitHub read-only queue main, which represents the main is not always main, depends on the branch that the merge queue is currently targeting. In our example, we have one merge queue for main, so in our example, it will be main. And then the PR ID, and the headshot of that PR. And if PR before you, now this is something that we need to remember, that if I'm creating a merge, if GitHub is creating a merge group branch containing PR ahead of me, so if a certain PR is removed, maybe manually, maybe it's failing the checks, a certain PR is removed ahead of me, this should change my merge group. So this means that all the checks I ran on this current merge group are irrelevant. We need to construct a new merge group without that PR that got thrown away, and then we have to run the checks again. So the queue of PRs might change, and it might affect the merge group branches that are created. They might need to reconstruct and run the checks from scratch. So if a PR before you is removed, merge group for you and everyone after that the PR is entered has to be recreated, and checks need to restart on the new branches that was created. Let's see an example of what we're talking about those special merge group branches, how they're constructed, and we'll see an example of a live example of those merge group branches. Okay, so let's examine a live demo of those merge group branches that are created when our pull request is entering the merge queue. So to demonstrate how those branches are created, I modified the build workflow a bit, and the build is running on the merge queue, is also running on pull request. The build is a required check. It's created, this creates a check, and the check is required. So it contains a single job, and now what the job is doing, in case it distinguishes between if I'm running in the merge queue or if I'm running on the pull request. So I have one step with a condition that if my event is merge group, this means that if I'm running in the merge queue, I'm going to sleep for 9 minutes. And the second step is if I'm running on a pull request, I'm gonna just pass the check successfully. So what we're doing is delaying the run in the merge queue. So when the pull request is entering the merge queue, we can have more time to examine the branches that are created in the merge queue for each of those pull requests. And for this, we'll create two pull requests. So one pull request, we're going to create a branch. And we're going to name that branch, let's say, test merge group 1. And in this branch, I'm going to create two commits. So I'm going to just copy paste a text file that contains bar and name that text file 28. And I'm going to do git status. This is going to be my first commit. Created first file, and I'm going to create another commit just by copy pasting this file, and I'm going to rename that file 29, and then I'm going to create another commit, created another file. Great. So my pull request contains, very simple, two commits. It's going to pass on the pull request, and on the merge queue, it's going to take a while. So I'm going to push my branch. And then I'm going to go to the repository, and I'm going to open a pull request. And while this pull request is going to run the build, I'm going to click merge when ready, confirm merge when ready. So what it's going to do is going to transfer this pull request directly to the merge queue after all the requirements is met. And since the build runs in the pull request right away, it already entered the pull request, the merge queue. So now we're going to create a second branch. I'm going to return to main and check out a branch test merge group 2. And in here, we're going to create another file. And we're going to commit this file, just contains a text file, created third file. And we're going to push this branch. And we're going to go back and create another pull request. And in this pull request, we are going also to enable merge when ready. So this pull request will also enter the merge queue. So now I have my merge queue contains two pull requests, right? So if I go to my merge queue, I should see that I have my first pull request and then the second pull request. I have two pull requests in my merge queue. So now if I do git branch, currently I have only the third branches, main test, the branch for the first PR, the branch for the second PR, and main. Now I'm going to do git fetch. And git fetch is going to the remote repository, is going to examine different branches that are created there. And if I do git branch now, I should see that it grabbed a new branch, GitHub read-only queue main PR 50, this branch, and it created another branch, 51. So it created two additional branches that reflect the read-only branches that are created in the merge queue. Now I can do a git log command, to view those different branches, how their commit relates to one another. So I can display it in a certain graph. So for this, I'm going to get the branch name, compare it to origin. So GitHub read-only queue main PR. Let's start with PR50. And the SHAV PR50. And we'll do the same for PR51. And this should display us a log graph display of how our PRs are arranged, how our merge group are arranged in relevance to main and each other. So you see that you have a bunch of commits in main, and then main is at a certain point, at this point, and after this point, the head of main, they're created the 50 pull request with the commit, the latest commit that we saw, and we have another merge group branch that is created ahead of me. Notice that although the pull request number 50, we created 2 commits for that pull request, still we only see a single commit ahead of main. So it squashed those commits. So remember, in our settings, we specified that all the pull requests in the require merge queue should be squashed and merged based on this settings. If the setting was different, for example, merge commit or rebase and merge, we would have seen, well, we wouldn't have seen either merge commit, a single commit, or we seen if we rebase, we would have seen those 2 commits ahead of me and then my PR number 51. So depending on what you choose, this will be how the merge group is going to be reconstructed. This is why we recommended to use the same way you merge your pull request, the same option that you use when in the require pull request before merging, developers, we can eliminate how they merge their pull request to only squash. And I would prefer that the same merge group will be created in the same way. So it's going to be, how it's tested is more, will match more how the future state will actually be. So I don't want to use rebase if at the end result, this pull request will be merged with squash, because it's going to construct a different merge group than what will actually be in the main. So I want it to resemble more how the main will look like. So you see in this log view how GitHub constructed those merge group branches, how it arranges main. On top of main, it placed the PR50 merge group, and then on top of that, in a single commit, squashed the commit of PR50, and then on top of that, it placed PR51. So it really constructed a branch that contains all the PRs ahead of me. So PR51 contains all the PR ahead of him, and in addition, the latest main and every PR ahead of him. So this is how those branches are constructed. Those branches are read-only. I cannot push changes to them, but you can actually examine how those branches are constructed to understand how merge group branches are created. So we saw an example that when a PR is entering the merge queue, a special branch is created for that PR that contains the latest main and every PR ahead of me in the queue, and then the PR that actually is being checked. So this creates reliability for the checks and makes sure that all the checks run on the latest main and on what the main will look like in the future state, all the PRs that's going to be merged before me. So just to emphasize what happens using a diagram, so we have an empty merge queue, and now a PR is entering, the first PR is entering the merge queue. Now, when a PR is entering the merge queue, it doesn't matter if this PR is already aligned with the latest main or is not aligned. In any case, a special branch, a special read-only branch, a merge group branch is created for that pull request, taking the latest main and placing the PR ahead of the latest main, and then starting to run the checks. Now, another PR is entering the merge queue. Now, this PR might not run the checks yet. This depends on the settings, rules, rule sets. The settings that we have here, we have concurrency settings. So if I go to the merge queue settings and I open that, I see that we have build concurrency. The current value here is 5, so we can have 5 parallel merge group branch running the checks. So since it's 5 and there's only 2, so we can run the checks in parallel. So a merge group branch is created for PR 91, containing the latest main, containing the PR that is ahead of 91, which is 123, and then 91, and then running the checks against this branch. Now another PR enters the merge queue. Since our build concurrency is set to 5, it can run the checks in parallel for this pull request as well. So it's creating a merge queue with all the PRs ahead of me and then starting to run the checks. Notice that with merge queue, we have a faster velocity because checks can run in parallel. And so it means more pull requests are going to be merged faster to main. So we have those three PR checks running in parallel. Now it doesn't mean that the order of the checks will pass according to the order of the queue, but the order of the queue does determine which one is going to be merged first to main. So in this example, 150, the last PR in the merge queue, the checks passed first. So it can destroy the merge group branch, but now it just waits, right? Because it needs to wait before its turns arrives that he can merge to main, before the other PRs are merged to main. Now 91 is passed, the merge group branch is destroyed as well, but he has to wait as well because there is a PR ahead of him that has to be merged before we can merge 91. We need to wait for 123 to be merged. Now 123, the checks failed. So if the checks failed, the merge queue might decide, and I'm saying might because there are certain situations, if you saw 91 and 150, both of them had in their branch, they had PR 123 and they passed. So I'm saying 123 might be kicked out because there is settings that relates to group, and there is settings that relates to require all queue entries to pass required checks. And those settings might make the merge queue decide that even though the checks failed in 123, since it was checked in a group in 91 and in 150, it's still going to be merged although it failed. But in this example, the merge queue does decide that the checks failed, because require all queue entries to pass means everyone needs to pass the test. So in this case, if the checks failed, it will kick out PR 123. Now, what can you do? Because 91 passed, but it passed when it has the checks running 123. This means that it passed, the checks are irrelevant on the merge group branch that is passed. It needs to recreate the merge group branch without PR 123 before it, just with main and 91, and start to run the checks again. Same thing for PR 150, right? So it needs to recreate the merge group branch without 123 and run the checks again. This is why the build concurrency, you might want to play with it, maybe make it lower if you have more flaky test percentage. So you might play with this because it seems like, hey, I would like concurrency, right? I like faster velocity, faster pull requests to be merged. But if you have a lot of flaky tests and a lot of pull requests are thrown from the merge queue in a high percentage, so you might want to reduce the build concurrency. So not a lot of merge group and checks will be thrown to the garbage, and not a lot of compute time in the CI will be thrown. So you might want to play with it if you have a higher percentage of flaky tests. So we're running the checks. 150 again passed first, but it has to wait. 191 passed, and now everyone passed in the merge queue. The first one passed, I can merge 91, and then I can merge 150. So we saw here in the diagram an example of what happens to your merge group branches and what happens to your checks when actually a PR, the merge queue decides to throw a PR. In that case, merge group branches might need to be recreated, and checks might need to rerun again before those pull requests in the merge queue can be merged successfully to main. So as demonstrated, when a PR is entering the merge queue, a merge group branch is created containing the latest main and containing every PR ahead of me and then my PR, every PR ahead of me in the queue. Now, we might have conflicts when the merge group branch is created. For example, let's say PR 91 and PR 150 are touching the same file. When a merge group branch is created for PR 150, it means it needs to take PR 91 and then place 150 after it. And during that process, we might have conflict, which would cause a fail to create the merge group branch. So this is a scenario that might happen, that everything passed, your PR doesn't have conflicts with main, but when your PR is moving to the merge queue, it might have conflicts with one of the PRs that are already in the merge queue. So the PR cannot enter the merge queue if there are conflicts with main. So usually if you have conflicts with main, you solve them, and only after you solve them, your PR can enter the merge queue. So this is kind of a prerequisite before your PR can enter the merge queue. After you solve your conflict with main, your PR can still have conflicts with other PR. So conflicts with main have to be resolved, but when you enter the merge queue and the merge group branch is created, that merge group branch creation might fail due to conflicts with PRs that are already in the queue. In case you have a conflict with another PR, there's a few things that you can do. If possible, you might see the conflicting file and you might remove the changes from that file, maybe move it to a different PR and then prevent that conflict. So this is one option. It's not that common. Usually it's not a use case you can do, but sometimes you can take the conflicting file, take it out of your PR and maybe move it to a different PR. You can wait for the PR ahead of you to be merged. You have a conflict with a PR, you might wait for that PR to finish running in the merge queue to be merged to main, and only after it is finished, click the merge when ready and push your PR into the merge queue. Or if you think you have conflicts with a PR and you somehow think that those PRs are related, you can create a stack PR, meaning instead of taking your PR and creating a pull request to be merged to main, you can create a pull request to be merged to the conflicting PR. Usually you do it in a stacked PR situation when those assignments, when those features that of those PR are related somehow, then you can create your pull request to be merged to the conflicting PR. Now, this will obviously pop the conflicts sooner, but it won't jump your PR in the merge queue because our merge queue is only running on main. You don't have merge queue for pull requests that are merged to other PRs. But it will help you solve the conflicts, run all the CI checks, maybe cache some checks during those CI run, and then when the first PR emerges, your run will jump to the merge queue, only run a bit faster. So this is another option, creating a stacked PR and maybe floating those conflicts a bit early and maybe making the process of when the first PR merges, making the process of your PR merges a bit faster. So we can demonstrate those PR conflicts. You can see an example of that. For example, if I go to the code base, I can git checkout -b example conflict 1. Let's create a branch called example conflict 1. Let's have file number 32. I'll duplicate it, call it 33. And this file contains bar. So git status, I added a new file. I can do git add, git commit, added file 33 with bar. So this contains a single commit. I want to push this to our remote repository, and I'll create a pull request. So I'll create a pull request, and I'll merge when ready. When the checks, it's gonna jump ahead to the merge queue. Now we can go ahead and create another PR. I can git checkout -b example conflict 2. Again, create the same file 33, so we'll have a conflict, only this time instead of bar, I can name the text here foo, so we'll have difference and we'll have a conflict. So now I'll create another PR. 33 with foo. I'll push my branch. I'm going to create a pull request. I'm gonna choose merge when ready here as well. So we'll wait a bit for the build to finish, and then we'll take a peek into the merge queue. So the build is finished, it's moved to the merge queue. Let's go ahead and click the merge queue. We see that we have 33 with bar, 33 with foo, and then we should have, we'll wait for this to create the merge group. We should have a conflict soon. here we have a merge conflict. Okay, another option you might want to do, you might decide that the other PR might be more important than this PR, and you might want to jump it ahead in the queue. So you might do something like this. You can jump queue the merge conflict. Yes, I'm going to jump the queue. So now this will jump first. Let's see if it will work. Okay, so it's jumped, but okay, so it ran. It's running now. The other one is pushed out of the queue due to the conflict. But if this is another option you can do, you can jump the conflicting one. You can change the order. You might want something that is more important. You might want to jump ahead. So this is another option you have. Now the pull request that the first one, which is this, is kicked out of the merge queue. Or is it the second one? I'm sorry. So this one is kicked out of the merge queue, and the other one is running. So this is another option you have. So you see, you have. Let's do this again. Confirm merge when ready. A problem that is they're a bit annoying is you don't really know why your PR is conflicting. You might have not one PR, which is easy. In our case, you might have 3 or 4 PRs ahead of you, and you might have conflict, and it's not really saying with which PR you have conflict or with which commit you have a conflict. So it just says we have merge conflict without specifying too much information. So it's a bit hard to find those conflicts. If you do want to stack your PR and solve those conflicts and understand which PR is touching the same file, it's a bit harder to do. But you see here an example that when you have conflicts, the merge group might fail, and it can float an error that it had a merge conflict when it tried to create the merge group branch, and it didn't really manage to put the PR in that merge group branch because it contains conflicts. So as we mentioned, few options. You can either wait for this and then solve the conflicts. We can create stack PR. We can jump this up in the queue, a bit further in the queue than just float the problem in this PR. Just jump it in the queue. So a few options you have, but in general, if you have conflict with other PR, the merge group branch cannot be created. So now that we're inspecting different scenarios of how the merge queue is working and how it deals with conflict, with merge group branches and different scenarios in your merge group, I want to talk about merge group changes, merge queue changes. Those are changes that you can perform in the merge queue. You have a merge queue, you have 5 PRs in that merge queue. What can you do? What controls do you have in the merge queue page? And to experiment with that, we'll create 2 PRs and transfer those PRs to the merge queue. Those PRs will not have any conflicts. So we're simply going to create a branch called merge queue changes, merge queue changes 1, and just create a file called 34. And I am going to add this file and commit, calling this commit and inspecting the merge queue changes and controls 1. So this is our first PR. I'm going to push it, MQ changes 1. I am then going to create from this branch a pull request. So I'm going to the repository. I am going to create a pull request, and I'm going to create that pull request. And that pull request, I'm going to automatically, if all the checks here pass, I want that pull request to automatically be transferred to the merge queue. So I'm going to merge queue and confirm when ready. Then I'm going to create the second PR. So I'm going back to main. I am going to create a new branch called merge queue changes number 2. And I'm going to create a file. I'm going to name this file 35. And I'm going to create, I have a new file. I'm going to add commit, inspecting the merge queue changes and control, commit number 2, and then I'm going to push this branch, this new branch, and I'm going to create a new PR. So I'm going back to my repository, create a new pull request, create a pull request, and I am going to merge when ready the second pull request. So right now we're going to have 2 pull requests in our merge queue. Now let's see what we can actually do with those 2 pull requests that are in the merge queue. So we're going to the merge queue, and let's inspect the controls that we have here. We see the 2 PRs are in the merge queue. We see the order that the PRs are placed in the merge queue. So this is the first PR, and the order is based on the PRs that entered the merge queue. So let's go back to the slide. So we have one option that you can do is you can manually jump a PR to the front of the queue or remove a PR from the queue. So let's see how we do that. We have on the right side, we have jump queue. So I can take, for example, this is the second PR in the queue. So I can jump this ahead and I'll jump the queue, and I'm getting a confirmation, because what happens that if you jump someone ahead of the queue, this means that all the merge group branches that are created need to be recreated and the checks need to run again, because it changes the order that the merge group branch puts PRs. It changes the order of the PRs, so it needs to recreate those merge group branches. So this is why I need this confirmation, because this action is, I won't say destructive, but it is going to throw those checks, those merge group checks that were done on merge group branches that are going to change, is going to throw them away. So yes, I'm going to jump the queue, and number 2 is ahead of number 1, and they're going to restart their recreate the merge group branches and restart the checks. Now, if you go in the actions, you can see the checks that are running in the merge queue. So right now I have 2 builds that are happening, because I have the 2 old builds. Notice that the 2 old builds are still running. They are not canceled. This is actually, if I'm not mistaken, there's an issue on that those should be canceled, but they continue running the old builds, and they're also running the new builds. Those are the 2 builds that are up ahead now. So this is an issue that was raised. So why aren't the old build canceled, and you pay for the extra compute that are actually going to be thrown? So this is the jump queue. What you can also do is you can remove from queue. So you can remove a pull request from the queue. For example, I can go and click the remove from queue. Obviously, if I move the first one, again, it asks for a confirmation, because this is going to affect the merge group branches. So this means that the build that is running for the PR in the end of the queue will have the merge group branch need to be recreated, and the build will run again. So yes, I'll remove this from the queue. So this is another option we have. And sure enough, we should see a new build would be added soon, because it needs to recreate the merge group branch. And we should see an extra build. Once that merge group branch is created, we should see an extra branch, and there's a build again. Now, notice that those are 4 builds that are going to run. They're going to take, our build workflow has a merge group that runs 9 minutes. So each of them has a 9 minutes compute that is basically thrown to the garbage. Doesn't make sense and should not run. So this is an issue that was reported and still not fixed. So this is regarding the control. You can jump pull request ahead of the queue or remove a pull request from the queue. You can actually, so we noticed that we can view the merge queue state at this URL. We can obviously inspect the checks, right? So in the queue, when I'm going back to the queue, I have the checks here that I can click, and I can see them, and I can go from here to the actual actions and see, same as going to the action, I can see details about the running of the checks in the merge queue. So we saw that we can jump a PR ahead. We saw that we can remove a PR from the queue. Obviously, if someone is now running in the queue, so if I have something that, for example, this pull request is now running in the queue, pull request from MQ changes 1. Obviously, if I try to go back to this branch, while it's in the merge queue, and let's say I'm trying to add an extra commit, let's say git commit -- allow empty -m empty commit. So I'm creating an empty commit, and then I'm trying to push to my branch that is currently in the merge queue. I'm getting a remote rejected. So you cannot push changes to a PR that is currently in the merge queue, which it makes sense, right? When the merge queue finishes, it needs to merge that PR to the main as is, because it's running the checks on it. It can't accept changes. But if you want to change your PR, you're gonna have to go to the merge queue or click the remove from queue, remove it from the queue, then push the changes, then push your PR again in the queue. So those are the changes that you can do in the merge queue. You have a nice view of the merge queue with the order of the PRs, where you can jump a PR ahead, you can remove a PR from the queue, you can see the details of the actions run. Notice that if you remove a PR from the queue or jump a PR ahead of the queue, merge group are going to be recreated, compute time are going to be rethrown with old checks that are not relevant. So don't play with it too much. Know the cost of playing it. Probably if you jump your PR ahead, some developers will get angry unless it's really important, because it's gonna delay a lot of it's gonna impact velocity, and they will have to run the checks again, and the PR might be delayed from merging. So those are the controls that you have on the merge queue to play a bit, jump a PR ahead, remove a PR, play with the merge queue, and make manual changes to the merge queue. So I want to go over the different settings that we have for the merge queue. So we said that to activate the merge queue, it's activated per branch. It's in the settings, in the rule sets, and then you can create a rule set. And in here you have an option, given that you are an organization. For private accounts, you won't see the merge queue, you don't have this option. So for organization, for public repository and organization, or for I think enterprise account, you have the ability to enable merge queue. So in here you have the settings for the merge queue. So we'll expand this, and I want to go over the different settings for the merge queue. So right now we have a merge queue that is enabled for the default branch, for one branch domain. Of course, you can have multiple merge queue targeting different branches. So specifically for this merge queue, also you can have a merge queue settings. We can place target for more than one branch. So this will be settings for all those merge queue that targets all the branches here. In this example, we apply only to a single branch main. So for this merge queue, let's go over the settings that we have here. And some of the settings we went over. So the merge method, as we mentioned, we have discussed how the merge group branch is created. So you have your PR, and then every PR ahead of you that is ahead of you in the queue. This is how, and then the latest main. This is how your merge group branch is created. And this merge method decides how it's going to place each PR ahead of you. Will that PR be a merge commit, or it's going to be squashed to a single commit? So what we suggest is to use the same merge method you are going to do for your PR. So usually I recommend working with squash and merge. So I'm doing the same thing for my merge queue. So it will create something that is reflects how the main will be. The merge group branch is going to reflect similar to how the main branch will look if we choose squash and merge. So I know that the merge group branch will be similar. So this is the merge method, which I recommend keeping it similar like the allowed merge method. So another option we have is the build concurrency. So build concurrency, how many merge group branches are going to be created? So checks will run in parallel. So we said that when a PR is entering the merge queue, that PR, we might create a merge group branch for that PR. And then we have multiple of those PR enters the queue, and we might have multiple of those merge group branches. Each one is created and running the checks in parallel. So this setting determines how many of those merge group branches can be created and run the checks in parallel. Now, as we mentioned, you might want to play with the settings depending on your flakiness amount. So if you have a lot of flakiness and a lot of PRs are being thrown from the merge group, bear in mind that other merge groups ahead of that PR, after that PR will have to be recreated. So this means that all the checks will be thrown, and then the merge group branch need to be recreated, and checks need to be rerun. So if you have a lot of flakiness, a lot of PRs that are getting thrown from the merge queue, you might set this setting to be a bit lower. So otherwise you might throw more compute time and wasted checks. So this is the build concurrency. The maximum group size, the minimum and maximum group size, and I want to show a demo of this. I didn't like the documentation on the minimum, maximum, wait time, and require queue entries to pass. So those are a bit, I think, unclear from the documentation. So I want to show a demo of what those settings are. But in general, the minimum group size decides how many PRs are going to be, the minimum maximum decides how many of those PRs are going to be merged together. And when I'm saying together, I place the quotes because you're still going to see each PR merged. But what I mean is, let's say I'm setting minimum group size for 2 and maximum group size for 5. So what this means, so if a pull request is in the merge queue, it's first on the merge queue, so it can be merged. It's passing all the checks successfully in the merge queue. Because the minimum group size is 2, it will not be merged right away. It will wait for another PR to enter and then finish all the checks successfully. So it's going to wait for that PR, and then after both of them are finished successfully, they're going to be merged together. The idea is, if you have a heavy deployment, to not run deployment, make the deployment a bit easier by batching PRs together. You're going to still see each PR merged separately, but the timing of the merge will be one after another instead of having sometimes between those PR. And the wait time decides how many time I will wait for that PR to enter. So I might wait for 5 minutes in this case. I might wait for 5 minutes, another PR entered, and then the 5 minutes did not pass. I will wait until the maximum of group size of 5 or above 2. So I will wait at least 5 minutes for either 2 or up to 5 before I merge my pull requests. So this is the group settings. Now the group settings, if you do not require all queue entries to pass required checks, if you have a group settings plus you have removing this check means that each merge group has to pass their checks. But if you remove this, you have some kind of flakiness protection, increased velocity, and the cost of some reliability. I want to demonstrate this. And this is a timeout for the merge queue. If you're running and status checks did not pass in 60 minutes, then it will fail. So we'll give an example soon of the minimum group size, maximum group size, wait time, and required queue entries to pass. But in general, the maximum group size caps how many PRs are merged to the base branch in a single batch. So the maximum that can be merged in a batch, the minimum plus wait time prefer merging in batches. So it's going to wait for the group to reach at least a minimum. But if the wait time is passing and there is no minimum, it's going to just merge the PR. So it doesn't mean that it will always merge 2 PRs together, because if the wait time has passed and there is only 1 PR, it's still going to merge that PR. Okay, so the wait time is just, I'm going to wait for either the minimum and the maximum to reach, to create a more robust merge of multiple PRs to ease up deployments. And requires all queue entries to pass. We'll show an example of this. If it's on, this means every merge group branch needs to pass. And if it's off, it's a bit more forgiving if you're part of a group and a PR that includes your PR has passed. It might be a bit more forgiving if your merge group is failed, but you have a PR that includes you and that's passed. So we'll see an example of those group settings. It's a bit unclear and it's a bit hard to understand from the documentation. I'll show an example of those groups just for it to be clear and just to understand this require all queue entries to pass required checks and the groups, because it has some kind of flakiness protection that we need to understand, because it might increase velocity in the cost of reliability. So it's something that we need to consider maybe to activate. So we'll give a demo for that we'll give a demo for that in the next slide. So I want to show an example of one of the settings in the merge queue. So we went over the settings and we went over a setting that is called require all queue entries to pass required checks. Now, I think the documentation on this setting is a bit unclear. Personally, I had to experiment a bit with the merge queue to really understand what this means. And I want to do an example just to explain the settings, because it presents some kind of flaky test protection in the cost of reliability. So it might increase velocity at the cost of reliability. So I want to explain with a demonstration. So first of all, I disable this option. Let's go over what it says. Require all queue entries to pass required checks. When this setting is disabled, only the commit at the head of the merge group, i.e. the commit containing changes from all of the PRs in the group, must pass its required checks to merge. So what does that mean? So let's say we have our merge queue is empty and a pull request with pull request number 60 is entering the merge queue. Now that pull request is going to be created a merge group branch for that pull request containing the latest main and then the changes that were made in PR 60. So that merge group branch, the checks are running on that merge group branch that is created. Right after PR number 60 enters another pull request, and let's say that pull request ID, pull request number is 61. Since we have build concurrency set to 5, we can run checks on that pull request in parallel. So a merge group is created, a merge group branch is created for that pull request as well, and that merge group branch contains the latest main, now all the PRs ahead of me, which is PR number 60, and then my PR number 61. And on that branch, we're running the checks. So notice that the later branch that was created already contains PR number 60 as well as PR number 61. What this settings means is we can forgive, if this setting is disabled, we can forgive if the merge group branch of PR number 60 is failing, we can forgive that and still merge PR number 60. If the PR number 60 checks passed on PR number 61, which includes PR number 60. Which means if the later merge group branch that contains PR 60 is passing, we're going to merge PR number 60 even though it failed its own checks. So to demonstrate what I mean is I modified the build workflow a bit. I reduced the wait time. If I'm in a merge queue, if I'm on the triggered event as merge group, I'm waiting for 3 minutes. If I'm in a pull request, I'm going to pass immediately. That was before, only we reduced the time a bit from 9 minutes to 3 minutes. Now this step, I added this step to demonstrate the require all queue entries to pass what it does in disabled. What this step is doing is checking if the PR is number 60, we are failing and exiting with 1. For all other PRs, we are passing. And what we'll do is I created those pull requests number 60 and number 61. So we'll start with number 60. This will be the first in the line, and it's supposed to fail the build workflow. So I'm going to push that to the merge queue. Now it will fail. What it will do, it will run for 3 minutes, and then it will fail when it reaches this step. But since we disabled the require all queue entries to pass, if a pull request is entering after that pull request and is passing the checks, we're still going to merge those two PRs, even though the first one failed. So let's go to the second PR. Let's click the merge when ready on that PR as well. And then let's examine our merge queue. Our merge queue now contains the first one is number 60, and the one after that is 61. Let's run this and see the result and see if those two PR, even though the first one is failing, if those two PR are, both of them are being merged to, at the end will be merged to me. Okay, so we waited a bit and we should see that PR number 60 will soon fail. Let's go to the actions and we see that the build here failed. So we should see in the merge queue that this failed. Checks failed on number 60. Yet although it failed, we should see that it still remains in the merge queue waiting for PR number 61. If PR number 61 is passing, it will still merge PR number 60. So it's going to wait. Even though it failed, the build failed, there is still a build running. So we might have a chance here. So let's wait a few more minutes until this second build is passing. Okay, great. So it's passed, and we should see the second build is success. And if we're lucky, we should see that the commits, 2 PRs are added. We see that PR number 60 is merged again, is merged as well, even though it didn't pass the checks. And PR number 61 passed the checks, and it passed. We also have an indicator here. So we saw what happens when you disable this. It might be a bit more forgiving. If the checks are failing, PRs can still be merged. If there's a merge group branch later in line that includes this PR and it did pass, then it will merge the PR even though it failed its own checks. So at the beginning of the lecture, we presented this diagram of what we call a quality merge process to main, a quality CI, quality checks, to measure how your the checks and the test and the lint, everything you run before you allow to merge your code. There's a quality for that. And we measure it by 4 pillars: reliability, how the reliability is, how well do I prevent bad code from entering the production branch or main branch? How well do I protect against digression, against previous bugs that I had? How well is the testing, is the lint? We measure it with velocity. How well can I run the checks quickly and merge my code to PR as quickly as possible? How the velocity of development, do the developers can create PR often and merge them often? Usually you can measure it by the amount of amount of new code that you manage to push to production. And we have also the cost, right? So everything costs money, the compute time costs money. So sometimes there are trade-offs between the pillars, right? Sometimes you want to save costs and it might cost you reliability. Sometimes you say, okay, I'm gonna reduce velocity, but I will add end-to-end test with multiple browser, which will reduce velocity, but add reliability. But nothing is perfect, right? Sometimes we have trade-offs. And this is what I wanted to talk about, for example, for require queue entries to pass off. So we experimented with the option in require merge queue that we disabled the require all queue entries to pass required checks. This means it allows us to merge pull requests that might fail in their merge group branch. So this is exactly a demonstration of I'm going to reduce the reliability in favor of velocity. So there's a trade-off there, right? So there is a reduceness in, you are reducing your reliability in the CI, but you might increase velocity. So those are the kind of trade-offs that we're talking about when we're creating those systems, and there is no perfection in software, right? We aim for progress. Sometimes there is change. There is sometimes change in the situation of the company. Sometimes you get from management that you have to save costs, and then you're trying to dig how you can save costs, and sometimes you pay for the save of cost and reliability or velocity. So there's certain trade-offs that you have to do that evolve with time. So this is exactly a demonstration of this setting. Require all queue entries to pass equal, you disable this option and you create a trade-off where you hurt the reliability in favor of velocity. So disabling require all queue entries to pass allows a PR to merge even if its own merge group run failed, as we showed in the demonstration, as long as the PR was also included in another merge group branch that passed successfully. So it failed in its own merge group branch, but passed in another PR merge group branch, which included this PR. So this can improve merge queue throughput, meaning improve velocity, improve the amount of pull requests that have a green light to be merged to main. But it introduces a trade-off, as we mentioned, in reliability. You reduce reliability. So, for example, if you turn this off, you have higher tolerance for flaky tests. So sometimes, I would say even all the time, if you're testing constantly your app, constantly building unit tests, integration tests, end-to-end tests, you're going to have certain percentage of flaky tests. Flaky tests are tests that in one run they pass, and without code change they might pass, and without code change they might fail. So you have higher tolerance of flaky tests because sometimes your PR failed because of a flaky test. So now you say, okay, if this test flaky, then if this PR passes another merge group, I'm gonna pass it. And it's kind of increased the tolerance you have for flaky test. So it reduced queue disruption caused by intermediate CI failures that are caused by those flaky tests. But on the downside, higher tolerance of flaky tests seems like a good thing, but on the downside, it can reduce the confidence developers have in their CI signal. If their CI signal is saying, hey, those end-to-end checks, we have tests and end-to-end checks that failed, the developer will automatically say, oh, it's probably a flaky test, I'm going to run it again, or I'm going to allow it to pass with this disable off. And I've seen it all the time. So developers will not dig. If they have a certain percentage of flaky tests, they will not dig into the test. They're gonna automatically assume that it failed because the test is flaky. And they might run those end-to-end checks again and again and again before they even check if the error might be real. And I would say that even if you stumble on a flaky test, it's nice to give developers a good incentive to not automatically run again or not automatically forgive those flaky tests, but actually dig into the test, see what the test is checking, and actually ask yourself, how can I make this flaky test more stable, solve this flakiness? Because that flakiness is a bug, and we aim to also improve the flakiness, meaning reduce the amount of flakiness that our tests have. And this is what we just discussed. It will weaken the incentive to fix flaky tests. Sometimes it's good to not have a forgiven approach to flaky tests, because it will force your developers to say, hey, I have to fix those flaky tests in order to increase my velocity and the team velocity, and to merge my PR and the team PR quickly. I'll look into this specific test and I'll try to solve that flakiness. So if you disable this, it might weaken the incentive developer have to actually fix those flaky tests. Potential for hidden merge order issue. This means that if I'm setting this option to off, this means that my PR can fail its merge group branch, but it's included in another merge group branch that succeeds and it might pass. And you might say, okay, this is due to flaky test, but there is also a chance that it is due to the fact that my PR introduced a bug, and somehow the next PR in the queue actually solved that bug. So it's not a flakiness, it's the result of bad code that is merged to main with a code that actually fixed that bad code, which means you did introduce buggy code into main. It's going to have, you have difficulty finding that using Git, for example, for debugging, it's going to be a bit difficult if you allow this code to even enter your main branch. So this is not a good thing if it happens, even though you introduced a bug that the PR did fix. It means you introduced a buggy code into your main branch. It might resurface. It will be harder to find bugs if that buggy code surfaces in another layer of somewhere in your software. It's going to be harder to debug. And as we said, we're increasing velocity, right? So we're forgiving those failing merge group branch if another merge group branch passed. So it's going to make more green light to PR to approve PR to be merged to main. So more PRs will be merged to main. It's going to increase velocity. So, and also it's obviously it can also reduce CA infrastructure cost. This is because if my PR is failing and usually I throw it out from the merge queue, now my PR is failing and I can still merge it. This means that the compute that was invested in running the checks is not thrown away. So it also saves some CI cost. So just to say that to go over this option, require all queue entries to pass required checks, and understand if you should select this or enable this or disable this. So it varies. It has benefits, it has disadvantages. I would say that in the most part, I enable this option in favor of reliability, in favor of being more strict with flaky tests. So in the most of the teams I manage and the project I manage, I turn this setting on. I like it on because I have a more, I would say, strict set of mind regarding development. But that's my personal opinion. It's important to weigh all the benefits and disadvantages for considering this option. So I want to discuss about the downsides of merge queues. So, because nothing is perfect, you have a lot of benefits with using merge queue, but there are also downsides that we need to consider. And I will say that although we'll go over the downsides list, although there is quite a few downsides, still if you're working with a team of developers pushing PRs frequently, I think merge queue is a necessary thing for the CI pipeline. So let's talk about those downsides. We talked about a really great benefit that with merge queue that I can keep my pull request checks in sync with the latest main or the latest PRs that are going to push before me on main. And this is a great benefit, but merge queue does introduce additional CI overhead, operational complexity with working with a merge queue, which means how do I detect the errors in the merge queue, debug them, and potentially longer merge time. So often you're in a large queue, you'll have to wait your turn, and sometimes you'll have to wait quite a while. So let's go over a list of those downsides of using a merge queue. So often there will be more CI execution. For example, let's say you have a pretty small throughput of PRs. So you manage to push PR and there are not a lot of developers in the team, so another PR will be pushed quite later. So in that case, your PR can be checked on the latest main, you'll have no race condition, and then you can merge your PR. If you're working with a merge queue, in that scenario, your pull request, after going to the pull request checks, will need to go through checks again in the merge queue. So there could be more CI execution. We would also mention that some CI executions are saved, right? Because we said that the pull request race condition, when there are a lot of pull requests and you keep needing to rebase your pull request and run just checks again. So this has also caused a lot of CI runs to be thrown to the garbage. But overall, if you're using a merge queue, you probably have a bit more CI executions considering the overall total. Higher CI infrastructure costs. Of course, if I have more CI execution, the CI costs will be higher as well. Increased merge latency. Sometimes you'll have to wait more. In that example, when we have not a lot of PRs are trying to be merged, you can merge your PR right away. Now you have to wait for the checks to run again in the merge queue. You also have might have a queue of PRs ahead of you, so it might increase the merge latency. Flaky tests have wider impact. So we said that flaky tests can cause your pull request to be thrown out of the merge queue, and every merge group branch will need to be recreated and checks need to be rerun. So it has a lot of impacts regarding the velocity of PRs, regarding checks that needs to be thrown. So flaky tests have more impact. It's harder debugging experience. You need to understand why maybe your pull request passed in your pull request page but failed in the merge queue. You'll need to go to understand what happened in that temporary branch. I know that the logs in GitHub Merge Queue and debugging tools are not that great, that the documentation is also not that good. Conflict with queued PRs, we talked about that now you need to worry about not only conflicts with main, this is what we need to worry about before introducing the merge queue. Now you can also have conflicts with pull requests that are ahead of you in the queue. We talked about this, we talked about what you can do in that kind of scenario, but sometimes your pull request is passing, going to the merge queue, and then failing because of conflicts. Another downside that we might have is limited flexibility while queued. This means that when your pull request is in the queue, you cannot push, you cannot change your pull request. You have to go to the queue, throw your PR out of the queue, and then you can push updates to your pull request. Operational complexity. In general, although we seen a simple solution of a merge queue, just go to GitHub Action, adding the merge group, and this was all we had to do. And although it's easier to integrate if you're using GitHub Action, there is still usually some complexity introducing merge queue into your CI. Usually it's not as simple as adding just a merge group, because the SHA of the GitHub commits in the merge group branch change that might affect other things. So maybe the GitHub context is changing, the event, what you have in the event. So usually you have to change more than just adding the trigger merge group. You have to change additional things in your GitHub Actions YAML. So there is some complexity regarding that. If you want to introduce additional caching, maybe save if your PR is in the latest main, you don't want to run the checks again, you have to implement some kind of caching to help enhance the speed. So there is complexity and operational complexity, also debugging, you might have bugs, and introducing Merge Queue to your CI pipeline. So although we've seen a simple example, usually in real life scenarios, it's a bit more complex introducing Merge Queue to the CI pipeline. So this is in general a list of those downsides. I have to emphasize that although there are downsides to Merge Queue, working with a team of developers, I would think Merge Queue is a must in the CI pipeline. So I don't want us to be fixed on GitHub as the only solution for Merge Queue. It's nice if you're working with GitHub Actions to integrate Merge Queue. If you're working with GitHub Action, it's probably the simplest, but GitHub as a Merge Queue doesn't have a whole lot of features. It's a pretty simple solution. And there are other solutions out there like Mergify, like Trunk, with more features and might be more suited to your use case. So we're not saying that GitHub Merge Queue is the best. I will say that GitHub Merge Queue is the easiest to integrate if your CI pipeline is using GitHub Action. In that case, you might say, okay, let's start with something simple like GitHub Merge Queue, and maybe I will progress as my team grows, the number of PR grows, my test and flaky test grows, maybe then I will change a solution. Another option is to choose another Merge Queue if you're not an organization, right? If you're not an organization, you won't have the option to, if you're a private user, you won't have the option to use GitHub Merge Queue because it's only open to certain plans in the GitHub plans choices. So you might not have the option as a private user to use a Merge Queue. So I want to discuss, the aim of this lecture is not to show other solutions. If you want a solution, if you're interested in me showing a lesson about Mergify or Trunk, so write down in the comments and we'll prepare a lesson and a lecture about a certain solution that you found. So this lesson is dedicated to GitHub Merge Queue. So I'm not going to discuss very thoroughly on the other solution. Just I'm going to present what I think are the best solutions and the main features, which let's say the killer feature, the feature that I like the most in those solutions. So as we mentioned, GitHub Merge Queue is really easy to integrate, especially if you're using GitHub Actions. If you're using GitHub Actions, you have your required checks. Those will run in a certain workflow, and you can add a trigger to run that specific workflow in the Merge Queue. If that workflow creates a check, it will create the same check in the Merge Queue. There are other things to consider. So your event context might be different on a Merge Queue. So you probably have a different object that you can play with. You have a different SHA. That's the commit SHA that is going to run in the Merge Queue will be different. It might affect certain things. So it's not as simple as just adding a merge group. Usually when you have a more real-time, robust application, it will be more work than just adding this trigger merge group. But it's still going to be, I think, the easiest solution to integrate if you're using GitHub Action. It's the easiest to integrate in your CI pipeline. So really easy to integrate in GitHub Action workflow. You open the rule set, you enable the require merge queue, and then you add a merge group in the workflows that you want to run in your merge group branches. And this is using the GitHub Merge Queue is often enough if you have a smaller team, not that much of PRs, not a lot of flaky test percentage. You might work with GitHub Merge Queue and it might be suited for you, and that's great. But however, native GitHub workflow, it's going to work well if you have low flakiness. It's going to work well if you have a predictable CI, no need for advanced queue policies. Sometimes you want your merge queue to be, for example, prioritized, to work with labels, and not to have a merge queue assigned to a branch, but to have different multiple merge queue that are open for different categories. But if you have a simple pipeline with low flakiness, predictable CI, and you only need basically one queue, GitHub might work well for you. However, when the team usually start to grow, daily PR count grows, the amount of flakiness has become higher. You have a lot of queue churn really increases. That might present GitHub Merge Queue might not be sufficient for you. So in that case, you might consider other alternatives. At the day of this lecture, I think the strongest merge queue solutions out there are Trunk, which are highly focused on flaky tests, detecting those flaky tests, solving those, quarantining those flaky tests, solving those flaky tests. And Mergify is probably the oldest solution, even before GitHub Merge Queue, even before Trunk, with I think the most, a lot of feature. They have much more feature. Both of them has much more feature than GitHub's native merge queue. And although they cost extra money, sometimes the cost for those solutions actually saves you CI time and actually saves you cost. So this is something to consider. If you have a lot, for example, flaky tests that is causing a lot of pull requests to be thrown out of the merge queue, if you're using GitHub, if you're using Trunk or Mergify, you have more control of those flaky tests, quarantine them, maybe be more forgiving for those flaky tests. It might save you a CI cost from all those PRs that are thrown from the merge queue and those reruns of the merge group that needs to be created and run the checks again. So it actually can save you some amount of money choosing Trunk or Mergify by saving you CI cost. So this is trunk.io. I'll place a link in the description. So their main focus is not only merge queue, but also help you to quarantine, eliminate flaky tests. So with a lot of features around flaky tests. And the other solution I'm talking about is Mergify. So Mergify is also probably the oldest solution for merge queue that I'm familiar with. So we're going to go over the main features of those solutions, not showing a big example of those features, but just to show some of the big features that those solutions offer that can save you time, save you CI costs, and why those solutions are, although they're harder to integrate, they are better than GitHub Merge Queue. So it might be worth it to invest the time to integrate those solutions into your CI pipeline. So I want just to go over some of the features that other solutions have that GitHub Merge Queue does not necessarily have. So we talked about Mergify and Trunk. So GitHub Merge Queue is great, especially if you're using GitHub Actions, easy to integrate. If you have smaller team, not a lot of PRs, it can be suited for you. But there are other solutions, as we talked, Trunk and Mergify. And when your amount of PRs, when your amount of flaky tests, your CI costs grow, you might want to consider those other solutions. So here are some of the features that Trunk and Mergify present. So first feature is direct to main. So direct to main is a feature that you can find on Trunk. So direct to main, merge to main. If your pull request is already up to date with the latest main, there is no one in the queue that's ahead of you, and the queue is empty, there is no really reason to place your pull request into the queue, run the checks from scratch, and then merge your PR. There's no one in the queue, and you already passed the checks, you might have a fast pass to merge directly to main. You don't really need the extra stop to go to the merge queue. So this is the direct merge to main. Skip redundant retesting and merge PR directly when they are already tested against the current tip of main. So this is a feature that if you go to GitHub discussion, GitHub community, and go to the discussions, you'll find developers complaining about this as early as 4 years ago. So it's a feature that was requested a long time ago. You don't really know what the roadmap of the merge queue, you don't really know what features are going to be implemented in the future or where it's going to be. And this is something developers complain about a lot of 4 years ago, and you see a lot of discussions like that. This is not the only one. And there is no one to tackle this problem, really a solid answer. Is it going to be implemented or not? So this is really a feature that was requested. you can implement something on your own, right? So you can implement a sort of a fast pass. I know there are, I've seen a GitHub actions, a GitHub custom action that might help you with that, but nothing that's highly adopted with a lot of stars. So when I used GitHub Merge Queue, I implemented a fast pass myself and said that if there are no one in the merge queue and I'm the only one and I'm already up in the latest up to date with the latest main, I don't need to run. I take a lot of things from cache. So I did some kind of a custom implementation for that, but it's really annoying that it's not baked in the solution. And for example, that this is something that Trunk is offering, direct merge domain. So this is a nice feature that I think is really usable, is really important. Flaky test protection. So there are some features also in Mergify and also in Trunk that helps you quarantine flaky test, protect against flaky test. For example, auto retries in Mergify. So auto retry in Mergify means that if your pull request is failing in the merge queue, you can retry again. Seems like an obvious thing to add, but it really helps against flaky tests, right? It's really a shame to just throw it out of the merge queue and throw every merge group checks that was created with this PR just because of a flaky test. So auto retry just makes a lot of sense. Just retry the checks again, right? Really simple and really makes sense, and also really helps you to protect against flaky tests. Skip intermediate failures. It's very similar to what we saw with with GitHub Merge Queue, that you can disable the required checks to pass for all the merge group branches. You can disable this option, and then if your pull request is included in another pull request and it is passing, like this example, PR1 failed, but PR with number 1 and 2 passed, and then it might allow PR1 to merge. So it's really similar to disabling that require all checks to pass in all the merge group. So a similar feature is also available in GitHub Merge Queue. Lower CI cost, so you can batch PRs. So this is the batching option. So for example, you can combine multiple PRs in one and just run the CIs on a multiple batch of PRs instead of creating concurrent merge group and running every PR separately. You can batch PRs together and run them once. You have a better developer experience. You have a dashboard for those solutions, so you can see exactly what happened, what passed, what failed. They run in a separate PR page, so you can see the run also in GitHub. So you have a better information also in your GitHub when you see a draft PR of what they ran. And just a suggestion, if you're using GitHub Actions, you might want to start with a simple solution. So you might say, okay, I'm going to start with GitHub native merge queue, and then if my team grows, my flakiness grows, then I will upgrade to Trunk or Mergify if I see that the need rises and I really GitHub merge queue is now insufficient for my development goals and development and my CI pipeline. So in this lecture, we dug deep on Merge Queue, and specifically we saw the GitHub solution for Merge Queue. We saw how important it is to integrate Merge Queue into your CI pipeline, especially when you work with a team that are issuing many pull requests to a certain branch. It becomes really critical to have some kind of tool to coordinate those PRs while maintaining the checks on the latest main, maintaining the checks on the future state of the main. So we saw that it solved the PR erase condition. We saw that without the merge queue, if you turn on the require checks to run on the latest main, we saw that there is a certain race, a weird race between developers. Every time a developer is merging their code, you need to rebase your branch, run the checks again, and then there is a weird race between the developers. And you need some tool to also keep the checks to be on the latest main, but also tool to coordinate the PR, the merge PR, so you can maybe run the checks on the future state of main, combining main with other PRs and then running the checks on that. We saw that there are downsides to merge queue, right? So you might need to wait more for your pull request to be merged because you're in line with other PRs that will be merged ahead of you. There might be queue churn with flaky test, meaning that flaky test might kick you out of the merge queue, which means all the merge group branches ahead of you in the PR will have to be recreated and checks need to be run. So maybe it might cost higher CI usage, higher CI costs. It's a bit harder, I think, in GitHub Merge Queue to debug if something happened in the merge queue. So you don't have that sufficient logs in the branches temporarily. So it's a bit harder to debug if you have some kind of issue in your merge queue in the GitHub native solution. And we saw also that there are other merge queue solutions like Trunk or Mergify. So you might think, okay, I'll start with something simple like GitHub Merge Queue and then proceed to a more advanced solution if my team grows or if my CI requirements needs a more robust solution. So as a reminder, this entire lesson, step-by-step guide, everything we talked about is available in the Academy site. I'll place a link in the description. Academy is completely free. You don't have to register, or we don't want your email. You just need to click the link in the description and you'll go to this article. Academy is a free, open source, so education platform for advanced content. If you like what we're doing here in Academies, feel free to click the GitHub link here. Everything is open source, and start us on GitHub and like, comment, subscribe. That's it. Thank you for listening, and I'll see you in the next lecture.